guys, this lesson is going to cover solving quadratics by completing the square. We are in Unit 7, and this is actually the fourth way you guys learn how to solve a quadratic. Just to preface this, this is going to be probably the more complicated of all the ways. Quadratic formula, which is the fifth way we learn, it can be complicated at times, but I would say that this is probably the trickiest one. It also only works under certain conditions, and we'll talk about that later on. Completing the square is the fourth way we learn how to solve quadratics. So this is way number 4. And it can be our trickiest way because of all the conditions and like all these little tricks inside of it. And just to preface, if you are not comfortable with simplifying radicals and you are not comfortable by solving by taking a square root, this lesson is going to be difficult because you do need to know how to simplify a radical and you do need to know how to take a square root and solve by using square roots. So the last 2 lessons before this one are crucial in order to do this one. So don't even watch the video for this if you haven't even caught up on the other 2. All right, so essential question is, what is the process for completing the square and how do we use it? All right, so back in Unit 6, we learned how to factor for the very first time, and we talked about solving by factoring a few days ago, but now we're going to actually try to solve this quadratic by factoring. So let's go ahead and try to solve it. Now remember, to solve by factoring, you want to try to keep x squared positive, and we want it one side equal to 0, which both of these conditions are met for this problem, so we can go ahead and try to start factoring. When you're factoring, you always try to look for a GCF first, and we don't have a greatest common factor here, so we move on to our AC method. Remember, AC method works when we have 3 terms, so let's go ahead and try that. Our A value here is 1, our B value here is 16, and our C value is 4. So I need 2 numbers, or not 2 numbers, I need A times C first. 1 times 4, which is 4, and B is 16. I need 2 numbers that multiply to 4, but add to 16, which is impossible. So back in Unit 6, you'd be like, oh, I can't factor this, I can't keep going, so I don't have any factors. It's not factorable at that point. So you're like, okay, I'm done. Okay. Now, those types of problems you can actually solve by completing the square, the problems that are not factorable. Now, you can solve them by completing the square only if there's 2 conditions that are met. So, completing the square can be used to solve when a quadratic is not factorable. Okay, so it's best when the quadratic is not factorable. If it's not factorable, then you want to try to use this. But again, it only works under certain conditions, which is again why it's not my super favorite way to solve a quadratic. Give me 1 second. I'm pulling something up right now. Here we go. Perfect. All right. Now this method works best under 2 conditions. So if these 2 conditions are met, completing the square is not the way you want to go. So this method works best when A is 1. Okay, so when your A value is 1. If your A value is 5, don't complete the square. It's not going to work. If the A value is 3, can't complete the square. A value is 7, don't complete the square. Only if A is 1. And B is an even number. Okay, it doesn't have to be even, but it works best when B is even. So your B value, you want it to be an even number. So in this case, B value is 16, it would work with this problem. And your A value is 1, and it would work with this problem. So your goal here is that you want to be able to solve it, but you just can't factor. Obviously, if you can factor it, then factor it. It's way easier than doing it this way. But if you can't factor it, then you use the process of completing the square. But it only works when A is 1 and B is an even number. All right, now I'm going to go over some vocabulary just to kind of show you what we're doing today, but I'm not going to kind of go that far into depth with it, and if you're really curious, you can come talk about it. But a perfect square trinomial. So a perfect square trinomial is the product of 2 binomials that are the same. Okay, so it is a product of 2 binomials that are the same. For example, x squared plus 8x plus 16 equals 0. All right, this is a perfect square trinomial. Now, you don't know that yet because you haven't factored it. But if I were to factor this and go through the whole process of factoring, I end up with x plus 4 parentheses x plus 4. So I factor this and I end up getting x plus 4 and x plus 4. And remember, what happens when we have the same thing twice? Well, you write it once, but you write it squared, right? X plus 4 squared. So this guy up here is considered a perfect square trinomial because it makes a perfect square with x plus 4 and x plus 4. So that's what a perfect square trinomial is. So we're basically going to take something that is a trinomial today and make it into a binomial that looks like that. Now, there is a shortcut, and I will show you that later. So your goal is to make your equation a perfect square trinomial. And to make it a perfect square trinomial, you're going to complete the square. Now, below here, I do ask you what the perfect square trinomials are, but I'm going to go ahead and skip that section because it's not super important. Because we're going to create them anyways, so knowing what they look like is not going to be a huge deal. So our goal is to make it a perfect square trinomial. I'm going to erase this word because that looks really funky looking from far away. There we go. All right, so there are some steps here, and we're going to go through them. It's going to take some time to get used to them, so it's just kind of a fair warning there. So steps to complete the square. The first step, typically when you're given an equation, you want it in standard form. Now, for the first two lessons with graphing and factoring, you want one side equal to 0. You don't want that here. You're going to rewrite the equation so that you have ax squared plus bx equals c. So you're going to have all of your x values on the left side and all of your numerical values on the right side. So anything that has an x attached to it or an m or an n, whatever variable is being used, anything with a variable is going to go to the left. Anything that's just a number goes to the right. So what I typically say, all your x's are on the left and all your numbers are on the right. After that step is complete, you're going to create blanks on both sides. Okay, so it's going to look something like this. It's going to be ax squared plus bx plus blank equals c plus blank. Now, why does it have to be both sides? Well, anything you add to one side, you have to add to the other side. So whatever we add to the left, we're going to have to add to the right, which is why we need a blank on both sides. The next step is you're going to add a value that goes on both sides. Now, to find this value, I'm going to go ahead and let you look. I don't know if you can figure this out, but I can go ahead and give you the value, and I'll show you exactly what actually, I'll go ahead and just tell you what it is, and then I'll show you how to use it. So you're going to add something that's called b divided by 2 squared on both sides. So you're going to add that value. That's what's going to go in your blank. So in these blanks right here, b divided by 2 squared is going to go in both those blanks. Let me show you what b divided by 2 squared means. So let me give you a couple examples to show you. So minus 10x plus 25. X squared plus 6x plus 9. Okay. All right, so let's go ahead and do that. B divided by 2 squared. Okay, so there's actually a pattern to get from B to A and B to A, and it's the same for both of these problems. So the pattern is you do B divided by 2 squared. So negative 10 is your B value here. If you do negative 10 divided by 2 squared, well, negative 10 divided by 2 is negative 5. And what's negative 5 squared? 25. That's how you end up with this guy right here. You can do the same thing with the second problem because it's also a perfect square trinomial. So let's take our b value, which is 6. So if we're doing b divided by 2 squared, that would be 6 divided by 2 squared, which is 3, because 6 divided by 2 is 3, and 3 squared is 9. And that's how you get your c value. So basically, you're going to do that so that you can make it a perfect square trinomial. Okay, so b divided by 2 squared is going to go in the blanks. It's going to take some practice. Once you do this, you're going to factor the left side, simplify the right side. Now, the factoring the left side, I'm going to show you a shortcut for this. So there's a shortcut. And then after you do that, you simplify the right side. Once that's all done and you have factored, the left side should look something like this. It's going to be x plus a number squared. That number, I'll show you where that number comes from, but it's going to look something like that. And then you should have equals whatever is on the other side. But your left side should look something like this. You should have parentheses and then a squared. And then after that, you're going to solve using square roots. So we're going to take the days before lesson, and then we're going to use that to solve. All right, so starting with number 1, let's look at our initial equation. X squared plus 16x plus 4 equals 0. This is the equation that we had at the very beginning that we could not factor. Like, we couldn't factor it, so you try to solve by using completing the square. To use completing the square with this problem, remember, your a value needs to be 1, which it is, and your b value needs to be even. A is 1 here, b is 16. Those are both met, so we can actually do this problem. It's going to be a little bit scary at first, so just kind of bear with me. I'm going to copy the problem over here so that I have a little bit more room. X squared plus 16x plus 4 equals 0. Okay, the first step of completing the square is you want all of your x's on the left and all the numbers on the right. You want to rewrite it to where it's ax squared plus bx on the left, and then your numbers are on the right. Okay, so that means that x squared and 16x can stay, but that 4 needs to move to the other side, so I'm going to subtract 4 from both sides. So I have x squared plus 16x equals -4. Okay, so now I have all my x's on the left, all my numbers on the right. The next step is you create the blanks. So I have x squared plus 16x plus blank equals -4 plus blank. Now, that blank is going to be the same number on both sides, you just don't know that number yet. To get the blanks, remember you're going to do b divided by 2 squared. Okay, well, what is your b value in this problem? Well, your b value in this, your b value in this problem is 16. So you're going to plug in 16 for your b. So we have 16 divided by 2 squared. Well, 16 divided by 2 is 8, and 8 squared is 64. 64 goes in your blanks. Okay, so far, hopefully we're okay. So first step, variables on the left, numbers on the right. The second step is you create your blanks. The third step is you fill in the blanks. The blanks are b divided by 2 squared. Once that is done, you have to factor the left side. This is the left side. Now, I'm going to factor this to show you something, okay? I'm going to show you that the answer, I told you what the answer is supposed to look like when you're finished. It's supposed to look something like this, okay? So, this is the long way, so don't do it this way, but I'm going to show you the long way. You can do it this way if you want to, but I'm trying to save you time, so let me show you what it would look like if you did it the long way. So the long way is factor like normal. So you look for a GCF, don't have one. Then you go, okay, A is 1, B is 16, C is 64. So you have 64 on top, 16 on the bottom, and you're like, okay, what two numbers multiply to 64 but add to 16? Oh, 8 and 8. Okay, let's rewrite this. X squared plus 8x plus 8x plus 64, right? Because you're splitting this guy up. Okay, so you keep going, right? So you're not writing, you're not doing any of this because this is the long way. Okay, you're like, okay, I have 4 terms I can factor by grouping. My first group is GCF of x, and on the inside I have x plus 8 left over. Okay, you do the second group, you're like, okay, GCF here is positive 8, so I have positive 8 on the outside of my parentheses, and what I have left over is x plus 8. Okay, you're like, all right, my parentheses match, so I'm doing this correctly. So then you put your GCFs in a set of parentheses to make your first factor, x plus 8, and then your second set of factors is your matching set, x plus 8. X plus 8 and x plus 8. If you have the same thing twice, how do you write it? You write it as x plus 8 squared. Now, all of this work is a lot for one problem. So here's the shortcut. I can get you to go from there to here in one step. Now, this only works for completing the square. But, actually, I'll go ahead and erase this. What's the shortcut, right? You know it's supposed to look like x plus number squared. So on this left-hand side, we're going to go ahead and put x and then squared. We just don't know what that number is yet, okay? So we know it's going to look something like this. How do you get the number? All right, this is the weird part. The number in the parentheses right here is a number that goes in the parentheses right here. So what number was inside the parentheses after you divided and everything? It was 8. So you're going to put positive 8 here, which is exactly what I got earlier, right? I had x plus 8 squared. I can undo all of this and show you that it was x plus 8. It was, right? So it's the same thing. So you know that it's going to look like x something squared, and it's going to be positive 8 on the inside because the number on the inside of your parentheses here is the same number as the number on the parentheses here. It is going to take a lot of practice to get used to that. It's weird, but it's a shortcut. So I'm showing you a shortcut to do less work. Okay, so you factor the left-hand side, right? Factor the left, which we did it by shortcut way. Simplify the right-hand side. On the right-hand side, I have -4 plus 64. Well, -4 plus 64 is 60. Okay? From here, you solve by using square roots. So I'm going to go ahead and write that here. Solve by using square root. Okay, so from here, after you factor and simplify, then it's just basically what you did the day before. You're going to take a square root of both sides, right? So on this side, the square root and the squared are going to cancel each other. So I have x plus 8 left over equals. Now remember, anytime you square root a number, it's going to be plus or minus, so it's going to be square root of 60 here. Okay, now Square root of 60, I want you to type that in the calculator, square root of 60. Not a perfect square, so you leave it at square root of 60 for now. Leave it for now, you simplify last, okay? The goal is, remember when you're taking square root, you want to get x by itself. So the next step here, I'm going to go ahead and subtract 8 from both sides. So I have x equals, remember negative 8 goes in the front, so negative 8 plus or minus square root of 60. Okay, is this your final answer? No, because you always want to check to see if you can simplify that radical. So I'm going to go ahead and move this over here so that I have more room. X equals negative 8 plus or minus square root of 60. Let's simplify that radical. So I'm going to go over here to the side, and I'm going to look at my radical right here. I'm going to use, actually, I'm picking the wrong colors over here. Okay, so let's simplify square root of 60. So I need two numbers that multiply to 60, so that'd be 6 and 10. Remember, I'm going to cross off 60 because I've used it. 6 would be 3 and 2. 10 would be 5 and 2. Okay, so I can't keep going. So you're looking for your pairs here. So I have a pair of 2s, so 2s are a pair. And then 3 and 5 are not. So the 2s become a pair. They go outside the square root. And then 3 times 5 go back in the house, right? 3 times 5. So it's going to be 2 square root of 15. So I'm going to go ahead and rewrite my answer as x equals negative 8 plus or minus. Remember, what's square root of 16 the same thing as? Square root of 60 is the same thing as 2 square root of 15. That's why we got to know how to simplify radicals before we do this. 2 square root of 15. All right, so this is your final answer. So you can leave it as this, or the other way to write your answer, you could write it as, or x equals negative 8 plus 2 square root of 15. And x equals negative 8 minus 2 square root of 15. So you can split up the signs if you want to as well, but you don't have to. Sometimes it's more work, but you don't really have to there. And remember, you don't keep going here because you do have a square root left over, so you do not have to split and simplify. So if you have only whole numbers left, you split, and you'll see that in a few problems later on. Moving on to the second problem in the notes, we have x squared equals 14x plus 15. Now we are completing the square with this problem, so remember the very first step of completing the square is that you want all of your x values on the left side and all of your numbers on the right side. So the first thing we're going to have to do is subtract 14x and move it to the left. We want to keep x squared positive as normal, so we want to make sure that we keep it positive if possible. So we have x squared minus 14x equals positive 15. All right, so it's in our form that we want for completing the square, right? We want our variables on one side, numbers on the other. The second step is to create those blanks. So now I have x squared minus 14x plus blank equals 15 plus blank. Okay, so remember we have a blank on both sides because anything you do to one side you have to do to the other side. Now remember what goes in those blanks, right? So our blanks, that's going to be that's going to be b divided by 2 squared. Well, your b value in this problem happens to, did I use blue in the last one? Your b value happens to be in this problem negative 14. Okay, so negative 14 is our b value. So plugging it into the formula, we have negative 14 divided by 2 squared. Well, negative 14 divided by 2 is negative 7 squared, and negative 7 squared is 49. 49 is what goes in our blanks. So we have 49 and we have 49. After you fill in the blanks, the next step is to factor the left side, simplify the right side. Now remember, there's a shortcut to the factoring, right? We know that it's going to look like x and something squared. We know that for a fact. I showed you the shortcut. We know that. Now we just got to fill in what's in the parentheses. Remember, the number that's in the parentheses here, is the same number that's in the parentheses here. Well, what number is in the parentheses over here? Negative 7. Now, yes, you could put negative 14 over 2, but you want to simplify that, so it's going to be negative 7. The number in the parentheses here goes in the number in the parentheses here. So negative 7 is going to go in our parentheses, so minus 7. All right, and then we simplify the right-hand side, so that's going to be 15 plus 49 is going to be 64. Okay? After you do that, you're going to solve by taking the square root. So we solve by taking the square root at this point. So I'm going to square root both sides. Okay, so it's a squared root and the squared cancel each other out. So I'm left with x minus 7 equals, now square root of 64, that's a perfect square. Always check. If you can square root the number and it comes out to be a whole number in your calculator, then you go ahead and write the whole number down. In this last problem, we had 60, right? Square root of 60 is not a perfect square. You type it in the calculator, you're going to get a decimal. So I leave it as square root of 60 and I simplify later. Whereas here, when I type in square root of 64 on my calculator, I get 8. Okay, and not square root of 8, just 8. All right, now we have square root of 64 is positive 8, but remember, you have plus or minus. Anytime you create a square root symbol, anytime you create a square root, you always put plus or minus. Just like over here, we created the square root of 60. That wasn't already there before. We created it, so we need to put the plus or minus sign in front of it. All right, once you're here, the next step is going to be to get that x by itself completely. So I'm going to go ahead and add 7 to both sides. Is this the same color that I use? Oh, no, I use purple. Let me go ahead and change it to purple, just so it matches. Okay, we add 7 to both sides, so we have, I'll move this over here so we have more space. We have x equals, now remember we're going to write the 7 in the front and then plus or minus 8. Okay, so the question is, do I split here or do I keep this as my final answer, right? Because on the last problem, I just kept it as my final answer, right? Except I had to simplify the square root. We don't have any square roots left over. If you don't have any square roots left over and it's just whole numbers, you got to split it apart. So notice how plus or minus means you could have 2 different answers. So either you have one case scenario where you have x is 7 plus 8, and in the other scenario, you have x equals 7 minus 8. Now, why do I split apart my numbers here, whereas I didn't in the last problem? Because these are all whole numbers. If you have square roots left over, you're done. If you only have whole numbers, you have to combine like terms. So x equals 7 plus 8, well, that's going to be 15. So one of my x-intercepts is at 15, 0. And the other one is going to be at -1. 7 minus 8 is -1. So the other x-intercept is at -1, 0. Okay, so again, different from the last problem because this one I didn't have to split up. I split it up to, show you that you could write it that way. But the reason why I can't combine these two is because they're not like terms. You can't combine a number and a radical together. But you can combine a regular number and a regular number together. That's definitely doable. All right, moving on to number 3, we have r squared minus 7r minus 24 equals -3r. All right, so we want to go ahead and move all the variables to the left side, all the numbers to the right side. So anything that has a variable needs to move to the left. So I'm going to go ahead and add 3r to both sides because we want to move the variables over to the left. Now again, the reason why I'm doing this is because I want it in that form, and I can only add it to 7 because they're like terms. So you have r squared, -7 plus 3 is going to be -4, and then we have minus 24 equals 0. So on the right-hand side, I have 0 right now. But I'm not finished because I have to go ahead and also move all my numbers to the right side. So that 24 has got to go. So I'm going to add 24 to the other side. Remember, variables on the left, numbers on the right. So we have r squared minus 4r equals 24. Positive 24. All right, so we move on. We move on, okay? What do I do next after I move the variables and the numbers? You add your blanks. So we have r squared minus 4r plus, oops, I did plus blank in green, plus blank equals 24 plus blank. And again, what goes in those blanks? Okay, let's calculate that over here. In our blanks, remember that is b divided by 2 squared. Well, your b value in this problem is -4. Notice how it's -4 right here. So let's plug in -4 to our formula. So we have -4 divided by 2 squared. Well, -4 divided by 2 is -2. But -2 squared is +4. So the number that's going to go in our blanks is +4. All right. Remember, the next step after you fill in the blanks is you factor the left, simplify the right. So remember, when we factor, we know it's going to be parentheses squared. Now, in the last few problems, we've used x. So that's why there's always an x in the front, because we have x in our problem. Well, what variable are we using in this problem? R. So we know it's going to be an r here. We just don't know what that number is yet. Now remember, I'm going to keep drilling this in your head because it's the shortcut. The number in the parentheses here is a number in the parentheses over here. So the number we're going to write in is -2. Okay, simplify the right. 24 plus 4 is 28. After you factor and after you, or factor in quotes, and after you simplify, you solve by taking a square root. So let's go ahead and take a square root. Take a square root on the left, take a square root on the right. On the left-hand side, the square root and the square cancel each other out, so I just have r minus 2 equals, now square root of 28. If I type that in the calculator, I'm going to get a decimal, which means I'm going to leave it as square root of 28. But remember, I created that square root sign, so I have to put plus or minus there. If I created it, I got to state that there's plus or minus. If it was already there, I don't need to do anything. All right, the next step is to get your r by itself. So we're going to add r to both, or not r, add 2 to both sides. Cancel that out, and I'm going to go ahead and move my work over here. So that's r equals positive 2 in the front plus or minus square root of 28. Okay, so remember, you always write your whole number in the very front. Always write it in the front. Just like when we're taking square root, you write it in the front. Okay, from here, is this your final answer? You got to think about that. Am I finished? And the answer is no, we're not finished, because you can simplify that radical. So I'm going to go over here to the side. What color did I use earlier? I used yellow. I'm going to go over here to the side, and I'm going to simplify square root of 28 and see if I can break that radical down. Sometimes you can, sometimes you can't. But I know that 28 is not a perfect square, so I couldn't square root it earlier. Well, the square root of 28, well, 28, two numbers that make 28 are 7 and 4. That's the first two that I thought of. And remember, we cross off anything that we've already factored. And then 7's prime, so I'm done with 7. But 4 is not prime, so I keep factoring that one, and I get 2 and 2. Remember, you're looking for any pairs. So I have a pair of 2's right here. And then this 7 is all by itself. So remember, when you're rewriting a radical, your pairs take out one car on the outside, so we have a 2 on the outside, and 7 single, so it goes back on the inside. So square root of 28 is the same thing as 2 square root of 7. So I'm going to replace square root of 28 with 2 square root of 7. So I have r equals 2 plus or minus 2 square root of 7, because I'm just simplifying that. Now you can go ahead and write this as your final answer, so you can write this and be done and call it a day, or if you want to, you can split it up. As always, you can always be safe and do that. R equals 2 plus 2 square root of 7, or R equals 2 minus 2 square root of 7. Because remember, the plus or minus means you could technically have two options. You can either write it as the plus or minus to keep it condensed, or you can write it separate and break it up. So it's up to you, whatever your preference is. I'm going to go ahead and fix this real quick. Oops, undo. Like that. There we go. All right. Moving on to the last problem of the on-level section. Okay, first step is we want to go ahead and put all of our variables on the left, all of the numbers on the right. So first of all, I noticed that there's a negative 2x squared on the right-hand side. I need to move that to the left. To move it, I would add 2x squared to both sides. And remember, you can only combine the like terms, so I would add it to the negative x squared on the front there. Well, negative x squared plus 2x squared is 1x squared. And then I have positive 2x minus 10 equals 0. I'm going to go ahead and make this a different color because that's not our first step technically. There we go. All right. I still need to move all my numbers, my constants, to the right-hand side. So I'm going to go ahead and move that 10 by adding it to both sides. So then I have x squared plus 2x equals positive 10. Now again, completing the square only works when your a value is 1 and your b value is even. Notice how a is 1 here, b is an even number. Just like in number 3, your a value is 1r squared, and then your b value is negative 4, also even. Number 2, a value is 1, b value is even. Number 1, a value is 1, your b value is even. It only works when your a value is 1 and your b value is even. B value doesn't have to be even, but the a has to be 1. And you'll see if you decide to do the pre-P section that your b value will not always be even. But if a is 1, you can technically complete the square. So there's a little bit of a mess there, but we'll get through it. All right. After you get all your variables on one side and all the numbers on the other side, you're going to add your blanks. So we have x squared plus 2x plus blank equals 10 plus blank. Now same process. What goes in our blanks? B divided by 2 squared. B divided by 2 squared. Okay, well your b value in this problem is positive 2. Oops. So we're going to plug in 2 for b, so b divided by 2 squared, so 2 divided by 2 squared. Well, 2 divided by 2 is 1, and 1 squared is 1. So the number that goes in our blanks is positive 1. All right, we're going to factor the left and simplify the right. Remember the shortcut to factor, because that's a perfect square trinomial, there is a shortcut. You have a squared here, and you know because you're using a variable x that there's going to be an x. Remember, same pattern as always. Now, what number is going to go in the parentheses here? Well, the number that goes in the parentheses here is the same number that goes in the parentheses there. So we have 1. Is that a positive 1 or a negative 1, though? It's a positive 1, so we make sure we put a plus 1 there. Equals 10 plus 1, which is 11. Okay, from here you're going to solve by taking the square root. Square root both sides. Anything you do to one side, you have to do to the other. Square root and a square cancel each other out, so I just have x plus 1 equals, now square root of 11. If I try to square root 11 in my calculator, I get a decimal, which means it's not a perfect square, so I'm going to leave it as square root of 11 for now. But remember, if I created a square root sign, I have to put plus or minus in front of that. That's the most common mistake. We forget that plus or minus sign. Okay, our next step is we're going to get x by itself completely because we're solving for the x-intercepts, right? We want to get x by itself all the way. You're going to subtract 1 on both sides. And I think I have some room. So x equals, now remember, negative 1 is going to go at the front, and then you have plus or minus square root of 11. And then you go over here and check to see if you can simplify square root of 11. But 11's prime. So can you even simplify square root of 11? You can't, which means if your radical can't be simplified any further, then this is your final answer. So this one wasn't too bad. If you had to simplify, then obviously there's a little bit more work. But if there is no simplifying necessary, then you are finished. So you could have it, you can also write your answer like this as well. So I'll go ahead and write it both ways for you. All right, so that is the on-level section.